Hello and welcome to another episode of Rustacean Station. I'm your host, Alan Wyma, and today I'm with Herbert Wolverson, who is the author of Hands-on Rust, which is a very hot book, I might add, right now, about how to learn Rust through video game development, I believe specifically 2D. And I brought him on the podcast to talk about, the current status of video game development, and also his book, because his book is very popular right now. I bought a copy, but just haven't cracked it open yet. It's on my list of the many other books I've been buying recently, usually all about Rust. And so, Herbert, why don't you go ahead and maybe give a quick intro about yourself?
Hi, thank you for having me. Like you said, I'm Herbert Wolverson, author of Hands-on Rust. I'm originally from South London, but I live in Missouri now, in the very center of the United States. Hands-on Rust is currently doing pretty well. It's out on Pragmatic Publisher and Amazon. It's a book that's really built to make learning Rust fun through the vehicle of game development. So the idea was that you don't want to necessarily read a very dry text if you're just trying to learn the language. You'd rather have something that's very hands-on, hence the name, has you running examples right from the very beginning. By the end of the second chapter, you have a Flappy Bird type game going. Then it dives into dungeon crawler type games, and all along the way, it's actually working through a curriculum built from getting you started with Hello World all the way up to slinging traits around, managing some memory. And the idea was that we're introducing all these difficult topics, sneaking them up on you, and you're using them before you really realize, hey, that was hard.
Sorry, hey, that was hard, meaning the topic is hard, but actually when you went through the book, it's quite simple, like the way you walk people through it?
That's right. So, Rust traits, for example, when you look at a formal definition of them, they look confusing. I mean, they look like we don't have object-oriented programming, so we decided to do something else. And for me, when I first came over from C++, I stared at them for a while and hadn't the faintest idea what I was supposed to do with them. Once I started using them for a while, I realized this is actually really ergonomic. So Hands-on Rust gently introduces them, starts by having you use other people's traits, and you get to see, hey, this can really help me out. Then you can start creating your own. And then you realize, that wasn't so hard, and because you've stepped through so many examples, or learning a little bit at a time, you're in really good shape.
Okay, yeah, I understand now. That's pretty interesting. Yeah, the traits thing is definitely something super unique to Rust. I don't know of any other language off the top of my head, at least, with this kind of idea. Can you talk a little bit more about how would you explain what a trait is to somebody who is coming from C++ background?
So coming from another language, you'd think of a trait as being like an interface. So when a structure or an enumeration or whatever implements a trait, you're accepting that trait's promise that if you implement this interface, then you can guarantee that code that uses that trait will work with your code. So one good example from Hands-on Rust is I created a trait that allows you to describe how navigation across a game map works. And you can attach that to your own map, and it doesn't really matter how you choose to store your map as long as you can translate through the trait. And this allows you to hand it off to some pathfinding code, which will return optimal routes for navigating the map. And so the trait acts as the lingua franca. It's the translation layer in between of saying, I expect to receive this type of data, and the promise that, okay, here's this type of data, and what do you know? You get the result you want.
Okay. Makes sense. Okay, so yeah, the way the book's done, right, is that you're approaching this as somebody who's totally new to programming, right? Or they actually have to have some kind of programming background.
It would be a good idea if you've at least written Hello World in some other language at some point. It doesn't quite start at the absolute beginning of open a file, put some instructions in order, and go into great detail of, what is a variable. But really, if you've done it in any language the equivalent of, for I equals 1 to 10, print I, then everything else you need is there. And that was kind of a conscious decision, too, because I started out saying I was going to start teaching the actual programming thing. And then I realized I only had 320 pages that I was supposed to use, and I still slipped up and used more than that. But there was just no way to fit that content in and still get to the point that Rust was going to be a beneficial language to be using.
Yeah, but that's the interesting part about Rust, right? Is that it kind of can fit to a lot of different problems. And let me ask you this question, because I hear different responses. What do you think is like the most beneficial part about using Rust over other languages, maybe even C++ in particular?
Obviously, it depends where you're coming from. In my case, I'd been using C++ since the late 90s, and I kept running into, in particular, concurrency issues, and Rust's promise of fearless concurrency was what persuaded me that I wanted to have a look. And sure enough, Rust does an absolutely amazing job of ensuring that you can't shoot yourself in the foot with making your program run in multiple threads, and then with things like Rayon, it becomes extremely easy to make your program spread out, use every core that you've got, really take advantage of your hardware. At the same time, with the memory protection, you can be pretty sure that if it compiles, it's going to run. It may not run perfectly, but it's not going to deadlock or shoot you in the foot, unless you've done something really spectacular with an unsafe tag. And one of the things that really caught my eye was when I started using an ECS, an entity component system, built a bunch of systems, fed them into the scheduler, had a look at my task manager, and my test game was using all 8 cores, and I'd never once issued a multi-threaded primitive. And to me, that was just amazing. This was after spending years of very, very carefully building up my STD threads, mutex wrappers, spin locks, and so on from the ground up in C++. And I'd got a pretty good handle in my head of how to make it work. But suddenly I come over to Rust, and it's, wow, this stuff's automatic. So for me, that was the winning point. That, and I'd used Unreal Engine for a while, and I was desperate to find something with slightly less overhead in terms of memory management.
Oh, really? Unreal is, as you're saying, is not that great for memory management?
It's good. It's you can tell that it's older than modern C++ because it goes ahead and implements its own garbage collector. And my experience was that as long as you're using the blueprint side of things, everything works flawlessly. Once you start getting into C++ scripting on it, then sometimes it's a little less than clear whether you use a modern-style smart pointer here, a raw pointer somewhere else, or if you inherited from UObject, their God object. It's a good guess. It's anybody's guess exactly when that object's going to go away.
Oh, that's weird. I didn't know Unreal had some kind of garbage collector. I thought it was all kind of, because it's written in C or C++, right? So I thought it was still, you had to manage it yourself.
Yeah, it's all C++, and they actually wrote their own garbage collector in C++ and then attach it. It only affects objects you create that inherit from their parent object. It seems to be a weird hybrid of garbage collection and cycles, and I just kept finding that when I tried to do something clever, it shot me in the foot.
Oh, well, that sounds a little bit dangerous. I always hear Unreal Engine is really, really good to work with. That's why I'm kind of surprised that... Actually, the most surprising part is that the C++ game engine is doing memory management for you. That's the most surprising part for me, but I can understand that maybe it makes game development easier, or maybe they can schedule the garbage collection at the right moment.
Yeah, Unreal 4 is a beautiful engine. I'm not trying to diss it here. And really, as long as you're using their blueprints or simple scripts, it works fantastic. It just works fantastically, and the number of things you can do is amazing. The garbage collection has apparently been in there since Unreal 1, believe it or not. I think Tim Sweeney said that was one of the first things he put in, so that he didn't have to worry about remembering to allocate and delete all the time. And I think that's a big win, and I definitely think you look at something like Unity that's using C# with its garbage collector. There's a much easier entry curve because you know that your object's going to go away, and you don't have to worry too much about accidentally, eating half your user's memory. On the other hand, when you start looking at high-performance Unity, you see all these posts about do this, this, and this, so the garbage collector doesn't get you. And then, so Unreal, they built the garbage collector in, and they made it a lot more explicit. Then you get over into modern C++ with smart pointers, and Rust, which basically cooks the smart pointers in, and unless you're willing to use unsafe tags, you're pretty much forced to do it. So with Rust, leaking memory is actually quite hard, unless you... one of the things that surprised me was that there is actually a leak memory command, because there are occasions where you may genuinely want to release the memory so that you can, for example, pass it to another process. So memory leaking itself isn't something that Rust guarantees won't happen, but you really have to try to do it.
Yeah, I think I talked with this guy, John Jinxet, a while back, and he said there's definitely some situations where you can leak memory if you're not careful. But I can understand what you mean by you have to kind of really, really work at it because that's just not the way the borrow checker and everything works. Actually, to me, there's big three. I'm going to go back to what you're talking about when you're comparing the game engines, right? To me, there's big three game engines out there. Of course, there's Unreal, which I think is probably known as the top dog. Then there is Unity, which you've also mentioned, but I think also Godot is another one that is kind of really up there, and it's really kind of growing recently. But that's kind of my take as an outsider.
If you do use Godot, there's a plugin that gives you first-class Rust support. It is very, very good. It can spit out Rust with a few annotations to help it connect to Godot. You can use it as a scripting language. It's fast to compile, very safe. I've started seeing a lot of posts in which people use it for the heavyweight part of the game, where, for example, generating a map, doing a bunch of heavy math, some physics, and then you let Godot do the rendering, input-output handling. And in many ways, it's a beautiful way to do it because Godot is really good at making beautiful scenes. And I love the way it's abstracted, so you can go off and script in Rust if you want to, and take advantage of both.
Yeah, it's kind of, when I looked at Godot, because I was trying to pick up video game development, I was looking at Godot. The reason I actually looked at Godot, because, like you said, they have first-class kind of Rust support. Well, I don't think it's first-class, but it's definitely supported by a lot of people. Is it G-native script, I think, or G-native or something? I forgot what they call that binding. Do you remember?
No, I know there's the native Rust binding. There's GD script, which has which itself can bind through to other languages. I've only used Godot a little bit because I probably spent the last year and a half working on book-related stuff and not a lot else. But the Godot native stuff is relatively new, and so I haven't got much beyond using it for effectively the hello world of game development.
Yeah. Oh, yeah. But what I want to say is that, there's a big three, right? Let's go back to what I was trying to say. And I think that Godot, if you're going to be using one of those big three, I think Godot is definitely the one to use. But the funny thing is that within the Rust community, there's really a huge segment of different game engines, right? There's Bevy, I think is probably one of the highest ones up there.
Yeah, Bevy is probably the most popular right now. And if Amethyst just ceased development, but Bevy really is Amethyst 2.0. They took the base idea behind Amethyst was to build an entity component system and build a whole engine around it. Bevy really just created a nice entity component system that doesn't hurt you. Its specs had some performance issues, and Amethyst were trying to switch to Legion, which is a beautiful piece of code, and it is really big. And the complexity of it scared quite a few people away. Although it got much better, but unfortunately unfortunately for it, Bevy came out and really streamlined a whole lot of things. So almost everything I see now is in Bevy, or it's the very low-level approach of let's take some building blocks like WGPU, which is a fantastic library that implements Metal, DirectX 12, Vulkan, and the new WebGPU standard. Abstracts it all. It's honestly quite hard to use. There's a huge amount of boilerplate to feed in because that's what those back-end engines expect to see. So rather than telling it to put a triangle on the screen, you're probably looking at a few hundred lines of code because you end up having to define what is a screen, what's the rendering pipeline look like. So where do I get what the triangle looks like? What shader do I run it through? Where do I feed it? What do I bind it to? And so WGPU can give you an amazing performance boost, but at the same time, it's massively hard work to write. So everybody's looking at things like Bevy to simplify that, because Bevy takes care of the boilerplate for you in most cases. Then there's some simple ones like Macroquad is very good. Bracket-Lib that I created for the Rust roguelike tutorial and hands-on Rust is not high performance, but it's designed to be a teaching engine. The idea is that you'll use it and all the concepts you pick up then apply to other engines. But Bracket-Lib goes out of its way to provide you with a friendly face. And I think there's room in the market for everything from really low level all the way to, I know Bevy's working on an editor and trying to start to get the Godot or Unity experience going. Where I'm mostly seeing people talk to me about Rust being used professionally for games right now is parts of engines. So Rust is really good at compiling in to other, linking into systems written through the C FFI, foreign function interface. And so I'd say I've talked to a bunch of people who've written the game in Unity or Godot, and then a chunk of it in Rust. And that chunk is the performance critical or the safety critical parts. I've talked to some people at some large game houses who probably don't want me to tell you where they work, where they're using Rust for internal tooling. So you might build parts of the map editor in Rust, even though you're not the customer-facing stuff that they see may not be using it yet. It's just starting to slip in. And it's the same outside of games, too, because Google, last time they rewrote the Bluetooth stack on Android. Parts of it are in Rust now. The Fuchsia operating system is mostly Rust on the back end and Dart on the front end. On Amazon, when you provision a new virtual machine on web services, a bunch of the stuff in the middle is Rust. So you're not talking to Rust at the front, and you're not running Rust on your virtual machine, or you probably not. But Rust is used in the pipeline in between, and that's really how Rust is starting to get used in the industry. Is it sneaking its way in, gradually growing, and that's part of why I think it's going to succeed. Is that it works so well with everything else.
Have you ever heard of the language called Zig?
I've heard of it, and it's on my list of languages to look at some point. Beyond, I've heard some people say amazing things about it.
Yeah, really. I've heard a lot of people say great things about it, and I heard of people using it in replacement of like C or even Rust. And I haven't heard anything negative about it, but I've heard some small negative things about Rust, like the borrow checker and these kind of things that are difficult to use. And then like there's some, of course, there's like Linux talking about like the things shouldn't panic, etc. Right? There's this kind of talk, but I think in general it's still quite high up on people's lists. People really using it, but. Yeah, I was just curious about like if you ever heard about Zig being used in video game development or in places, but maybe not, right?
I've heard of amateurs using it, but I've not talked to anybody in a big software house who's using it beyond occasionally playing with it. That doesn't mean it's not happening. It just means they haven't told me. So. Yeah.
So, okay, yeah, sorry, it's kind of a little bit off topic, but I was just curious if you've heard about anybody using Zig in companies and even in video game development, because like when I hear about Zig, it's always like Zig versus Rust. That's why I'm curious if you've heard anything.
Yeah, and from what I can tell, from what I remember, Zig started out, I don't know if it still does, transpiling to C. So Zig has an immediate advantage there that there's a C compiler for literally everything. whereas there may not be a Rust compiler for every possible target out there, just the ones that LLVM support. And I got the feeling from talking to some people on Discord that Zig is maybe not as obsessively clean as Rust, but it does solve quite a few problems. And so I could see Zig being like Rust, that it starts to slip in and use a few small be used for a few small parts, and then we'll see how they grow. And one of the great things about open source is that if Zig has a good idea, it'll probably be in Rust in a month, and vice versa.
Yeah, that's definitely true. And also, Rust just kind of keeps growing a little bit here and there. Anyways, sorry to maybe go back on topic, right? I want to talk more about your book, right? So you wrote your own engine, and you said you wrote it just for this book, or you already had it to begin with?
About a year before the book, I created the Rust roguelike tutorial, which is a big guide to building text mode roguelikes in Rust. And roguelikes are games based on the ancient 1982, I think it was, game Rogue, where you are basically an at symbol walking around an ASCII dungeon, fighting ASCII monsters. I really like using them as a way to get my feet wet with a new language, because they're almost infinitely expandable. You don't have to create beautiful graphics, which is good because my art skills are terrible. You get the sense of achievement the second you have your at walking around. Then he's walking around a nice dungeon. Now he's bashing monsters. And then if you really want to, you can keep adding complexity until you get NetHack, which gets to the crazy point that if you use the look command on a Medusa, it turns you to stone when you die. And they've just built in everything right down to putting potions on your arrows and infecting some other monster with confusion. And so from taking a language for a test drive point of view, a roguelike is a great choice because you can really keep adding to it until you're bored. And one of the things that I noticed when I started writing it was that there wasn't really a good back end for this. So I created Bracket-Lib initially as a way to graphically display the old DOS code page 437, which was the old Microsoft version of ASCII with additional, IBM version of ASCII with additional smiley faces and a few foreign language symbols and similar. And then it just kind of grew from there. And then when that hit Hacker News and my server melted from traffic, unfortunately, so I wound up getting a nice little VPS. Somebody got me in touch with Pragprog, and that's actually how I got into writing. Was they said, "You got 80 chapters of tutorial here. They're pretty well written. You've got a lot of people reading it. You should write a book." And I thought about it and realized, I've discovered I love writing. I'd love to write a book. So I went ahead and used Bracket-Lib because that way I could make sure that nothing changed and broke the book.
Okay. I think what I'm most interested in is Bracket is a video game engine, right? I just want to make sure I have the right classification for what it is.
It is. I would call it a video game engine for beginners. Mm-hmm. I fully expect anybody who's got through hands-on Rust and wants to continue making games to graduate on to a bigger engine, maybe Bevy. And the reason for that is that Bevy is really focused on going fast. Bracket-Lib is really focused on holding your hand and making sure that as you go through learning, you know what you're doing. You don't have any real opportunity to terribly mess things up.
What I'm interested in is if I was to make a video game engine, even for a 2D one, I'm aware that 2D and 3D is very difficult, very, very different. I mean, because 3D you have physics and everything else, but let's kind of just talk about video game engine just being very open, right? I really have no idea where I would start. If you were to create, when you created this engine, but let's just say for this one, what was the first piece, and how do you know how to create an engine? And I'm really curious about this part.
So I recommend everybody who gets to moderate skill level make a toy engine. It is a fantastic way to learn. And for me, I've made a few in C++ before I came over to Rust. So for me, the first thing I always do is figure out how to talk to the graphics engine in the computer. That used to be OpenGL or DirectX. Now it's got a little more complicated because Vulkan, Metal, DirectX 12 have all come along, and they're all similar, but they're not quite the same. So in Bracket-Lib's case, I went with an OpenGL engine to start with because I know OpenGL. And all that is really a thin wrapper over the OpenGL code built into your operating system and mostly provided by your video card vendor. So step one was get a window on the screen. And believe it or not, there's a surprising amount of work that goes into just getting a window on the screen and having the close button do something. Step two is, clear the screen. Hey, you're looking at a nice black window now. And then step three is I want to put something in there, whether it's a triangle. If you're doing 3D, everything's a triangle. If you're doing 2D, most of the time nowadays, you're actually using the 3D engine, but you're ignoring all of the math that turns it into 3D with perspective and just using X, Y instead of worrying about the Z or Z depth component. So once you've got a triangle on the screen, then the world is your oyster. So next you load up a texture, and now you've got a triangle on the screen with a picture. The cool thing now is you can draw two triangles and you've got a square, and almost every sprite in a 2D engine is a rectangle. And once you've drawn a rectangle, now you start working on how do I want to let the person who's writing a program put these rectangles on the screen. And so, I don't know, I went through a lot of different versions with Bracket-Lib until I found what I felt was a comfortable approach, where the engine does the hard work and it calls a tick function that you write, and the tick function interacts with the context, so you can say context print hello world at 1:1, and the engine worries about looking up the font, mapping where the characters actually are, putting them onto the screen. I know the first version of Bracket-Lib took me about a week. All I could really do was display was load a font file, which is actually just a bitmap of the old MS-DOS 8x8 character set from way back in the 80s, and copy those to the screen in the locations that match. So you have a pretend terminal, and you can tell it, 5.5, put an @ 5.6, put a hash symbol. And then after that, it's probably been 2 years of gradual improvement, making it, oddly enough, making it faster, so that it's not consuming too much CPU, because it's kind of embarrassing if you run a text mode roguelike demo and it's using 90% of CPU on a modern computer, when they worked pretty well in 1985. Yes. Sound is the one thing I haven't really tackled, just because I am really bad at audio. I'm kind of deaf. But I went ahead and put in quite a lot more support for different input devices. Touch devices turned out to be an absolute nightmare. And then a library called Winit started adding events for them. And suddenly it became easy, but I'd already done the work, so, well, I guess I learned something. And that's really, when people come to me and say, I want to make a game engine, or I want to make a game, the first thing to ask is which, because you're only really going to have time to make a game or an engine most of the time. And I've seen a lot of beginner projects spend 90% of the time on the engine and then realize they wanted a game as well and get discouraged. So for getting started, use an existing engine. For once you start getting into medium to advanced, in whatever language you choose to use, it's good to make an engine, and that making that engine will teach you an awful lot about how things work. But unless you're really good, you're probably going to end up still using somebody else's engine to make the game of your dreams. Like, I wouldn't use Bracket-Lib if I wanted to make an enormous Dwarf Fortress scale of detail game or a beautiful first-person shooter, I'd probably use Bevy or Godot. On the other hand, if I want to make something fun and simple, Bracket-Lib is great, and that's really where I've tried to position it.
Okay, no, that makes sense. I like how you broke it down for me because I started thinking about, yeah, that makes sense. Kind of reminds me of the expression of like, how do you eat an elephant, like one bite at a time, right? Really, break it down. How do I get the window coming up? How do I do this? And then the very last step was the most interesting where it's like, how would I want a user of my engine to interact with these different pieces? And I think that's the most tricky part. And like you said, I think you said you had to iterate quite a few times, right, to make that?
A lot of times.
A lot of times, yeah.
I'd say I was still iterating it right up until the first beta of the book was released. Because as soon as you've got a book out there that references that this is how it works, it can never change. Or you start getting angry email.
Well, unless, of course, you say, I only guarantee like 1.5 or something very particular, and then say, don't guarantee anything after this. And then you can kind of give yourself an out.
Yeah, so all the examples in the book are specifically locked to a version that I know they work with. On the other hand, I promise that I will try my very best not to break it in future versions so that you can enjoy the new stuff.
It's a very difficult promise to make, but I appreciate that you're trying at least, right? I don't know how much you can. Well, let's see what happens, right? Actually, something I want to ask, and I think you might have already answered this one, is if I'm an aspiring video game developer, and let's say that I'm interested in using Rust, or even any other language, right? Maybe I just want to get into video game development and using your book as a nice, easy way in. The way that you write the games, like if I complete your book, would I be able to say, okay, at a high level, at least I know how I can use, how I can do my code and use like Bevy or Godot or these others, right? Because the thing that I'm kind of curious about is like, I know that each engine is slightly different. Of course, they don't have the same interface, but it would be good to figure out like, can I have enough knowledge that I can switch engines with like minimal friction or something like that? Does my question make sense to you?
Yep, and the answer is that was part of what I was going for with the book, was to try and make sure you understand concepts as much as specifics. I was absolutely thrilled when, I don't know, about a week after the book came out, somebody sent me an email with pictures showing that they'd taken the game from the book and rewritten it completely in Macroquad because they liked that better. And I was like, yes, you got it. That was exactly what I was aiming for. And I know people have built it in Bevy. There was another one, the name of which escapes me. And one guy actually built his own engine and attached it to that. And so I was just thrilled because that's really what I was going for. Is I'm not trying to teach you to use my library. I'm trying to teach you to use libraries in general. The book spends a bit of time talking about entity component systems, which makes it a really great fit for Bevy, a good fit for Godot. Unity, of course, is getting one. I understand it's kind of in flux, but Unreal is really, with Unreal, it's got the entities and components. It just handles systems differently, so they're a little more of a learning curve for Unreal, but that's kind of the way it goes. Unreal has a learning curve, but it gives you, it's a trade-off. You get amazing power. Unreal can do stuff that I sit and stare at the demos and wonder how on earth my computer can do that, let alone Unreal. And the trade-off of that is you want to do something that cool while you're going to have to do a bit of learning. But so I hope that answered that.
Mm-hmm. No, it definitely did, right? That's what I'm curious about, because that's why I'm interested to take to read through the book and really grasp it, because I'm interested in doing game development just as a hobby, at least. Maybe if I have some real idea, maybe I can get more into it. But I tried going through a book about Godot. I kind of got it, but I think I don't really like the scripting language that they use in the book. That's just one that's built into it. It's like a Python-y scripting language. But in general, I did get it. But I also have a feeling that like Godot is actually a very visual kind of a way you work with it. Like you have the editor and all this kind of stuff. But I also feel like if you do like real video game development, you're still like more text-based and you're really writing code and all this kind of stuff. So I don't know. I have lots of thoughts in my head about this. But I think the big thing is that, like you kind of start touching on this one, is there's multiple different ways that you can structure your code, but for some reason it seems like everybody always talks about ECS, the Entity Component System. Why is that? And what other patterns could I be using? And is there a reason I should be using ECS only? Or this is kind of a question that always comes to my mind.
So ECS is actually a pretty old concept. It's just really only been formalized in the last few years. If you go back to early 90s through late 90s programming books about games, they all tell you to use object-oriented programming. So you create a base object, and then you might create a monster object, and then inherit from that an orc, inherit from that a wizard, and so on. And you start to get these giant trees with all of your entities in the game, like orcs, monsters, even battle axes, all defined somewhere in this giant object tree. And you start to run into issues of, well, what if I want the orc to be able to cast some of the spells the wizard can cast? And so with object-oriented programming, you end up making yet more objects. And if you're not careful, you wind up with this giant soup. And there's ways around it. There's also a performance issue that when you're inheriting, you go through what's called a virtual function table. So at runtime, the C++ runtime has to figure out, is this object currently an orc? Is it currently a wizard? Is it an orc wizard? And so there's a relatively fast, but still there, performance hit for it to jump to the right function implementation for whatever that object currently is at the time. And that's not really an issue until you start having like 100,000 orcs. But games started to hit complexity levels where, the giant battles you see in Middle-earth start to become possible. So developers started looking for a different way to do it. So ECS is more like, really should be broken up into two types. So you've got EC and S. So EC is entities and components, and is basically a storage database. I don't know if you've used SQL databases, relational databases, but it's really common to have an ID number representing, say, a customer, and then a whole bunch of different tables that all reference the foreign key of that customer's ID. Entity components work the same way, so the entity is little more than an ID number, indicating that this entity is number 12, or however you want to number it. And then components are broken down into tiny little structures that really just store some data, and any entity can have any component attached to it. You do want to be a little careful to avoid combining ones that make no sense, but that's more a logic problem than a storage problem. So what this gives you is more of a traditional business object access pattern where you could say, okay, give me, in this query, I want every entity that has a position and render information. And what it'll do is it'll iterate through and give you the entity ID number, where they are, and how you render them. So then you can put them on the screen. Now, the great thing is you go ahead and you implement 12 new monsters. As long as they implement those two components, then the code you've already written for rendering to the screen just works. Because computers absolutely love it when you store data contiguously in memory, so next to each other without jumping around, without pointer chasing, you get this massive performance boost because now you can store all of the positions in one part of memory, all of the render information in another part, and the cache is able to just read through the list. Later, newer ECS systems go so far as to say, well, you've got 20 creatures with this set of components, and actually store all the components together for absolute blazing fast performance. Generally, that's sort of an implementation detail I try not to worry about until I need it. But what the ECS does for you is it's called composition over inheritance. So instead of saying that this orc wizard is inherited from an orc, and then we'll add wizard code, you would say, okay, well, everybody's got a position and render information, but his AI is going to be following say, enemy AI spellcaster. And we might give him some components indicating that he knows how to cast fireballs, he knows how to fire magic missiles. And so you end up with something very flat. Now, the systems part of it is what I was talking about with queries. Systems are basically run a query, do one thing, and do one thing well. So the idea would be if you had a component for a cast fireball, and later on in the game you implement a dragon, well, you might decide that the dragon can cast fireballs, which may eventually turn into fire breathing, but you'll start with fireballs. So all you have to do is add the fireball component to the dragon, and now the fireball code that you've already written works, and that dragon with no additional code can already throw fire at you. Another example I like to use was in a game I was working on called Nox Futura, which is sort of a Dwarf Fortress type simulation. Once I got to the point of adding gravity, I added it to everything by adding one system, and then suddenly any character not on solid ground falls to the ground. But that applied to monsters. It even applied to a sword. So if you dropped your sword on the bridge and the bridge went away, the sword falls. Unfortunately, I forgot to exclude things that could fly, so all my birds fell to their death too. But that's kind of the joy of it, is that ECS is about doing something generic. It's very good for a sandbox or an open world type game. OOP just requires a lot more work to make sure your object tree is sane, ideally not go too deep. And they're both attempts to avoid having to reinvent the wheel over and over again. I just happen to prefer it, and I think the industry is moving that way.
Yeah, it seems to be like the only pattern I ever hear about, and I was just curious about if there's actually any other patterns. So you're saying OOP is definitely another pattern that you could use.
Very much so. Other than that, really you can store your data however you want, but those are the big two I usually see.
Okay, I think your explanation definitely makes a lot more sense, and that makes sense why ECS is always talked about, which is definitely because of things in my head. I thought ECS was kind of like you would build up, or I don't know how to explain it. But yeah, anyways, your explanation is actually really good for me. It makes much more sense. Okay, so in your book, right, you only really go over using Bracket-Lib. Do you also talk about any other game engines or flip to anything else?
I don't specifically tell you how to use them. At the end, I list a few that are up and coming and suggest that you look at them. The main reason I did that is that Rust engines are developing so fast that any book I write specifically on Bevy is going to be out of date by the time it prints, because it can take a year to get a book from starting to scribble to on the shelves. And like Bevy, for example, in that time I'd have missed 2 versions.
Yeah, I think Bevy is moving at a really remarkable pace, except for this last version. I think it's 0.6 is taking longer than expected for whatever reason. I had a chat with the guy who's working on it, and I asked him to come on the show, and he said after 0.6 he's willing to come on, but he's busy with his personal life and also with this engine, which is fine. I'm happy with that, but it's just interesting. Actually, I am kind of curious. If you could go through a couple of the engines. So you talked about, let's talk about the engines in Rust, right? We talked quite a lot about Bevy. That's the most popular one. I don't think we need to touch on that one. The one thing I always get confused about is what's the difference between Macroquad and Miniquad? And is one depend on the other, or what is it?
Let's see. I'm having to go from memory here, because if I remember right, one of them came first and then the other one was a reaction to it. And I can't remember which one came out in which order. But they both emphasized being a very thin layer that just helps you get some graphics on the screen, and not really trying to dress things up or push you into writing code in a certain way. The Macroquad I've used a little bit. I liked because it's really, really fast. If you just want to do something, just get something up and running quickly, it doesn't get in your way. It doesn't really hold your hand all that much either. So it's not necessarily the first one you go to. If I remember rightly, Miniquad is Macroquad even thinner. That's something you see in systems languages a lot, like Rust and C, is how small can we make this? I think I remember seeing somebody manage to put a demo together with full 3D graphics that fitted in 8K of RAM on one of the old 16-bit computers. And so that side of things is alive and well. And it does feel good when you know that you're really not wasting space. Let's see, I just blanked on the name, but one of the developers of Macroquad also works on the Rust Game Dev newsletter. And they seem really nice, and they're always just thrilled when they find somebody using Macroquad. So, I'd say give it a go and make sure you drop them in a line because it'll just make their day.
Okay, maybe I'll have to have a look at it. Okay, so we talked about Bevy, Macro, Miniquad. You talked about I don't know how you say that word.
Amethyst.
Amethyst. So I think I heard a lot of good things about that one, but then, I think within the last month or so, very recently, they decided we stopped working on it. I thought that was a super big surprise, but I also saw a huge outpour from the community saying, hey, we support this decision and we're very happy that you guys are stopping working on it, or I don't know how they say that exactly.
Yeah, Amethyst, way back when Rust was just starting to come into 1.0, Amethyst got started saying that we want to be able to use this for games. So they got the huge benefit of being the first people to really take it seriously. They spent a huge amount of time building up an entire graphics library that abstracts all of the major video card backends for different platforms. It's complicated, so then they built a layer on top of that actually abstracts that down into something human manageable. And then the Amethyst engine itself took all of that, added sound, glued on the old Specs ECS, and Specs was really the first good ECS system for Rust. It's a joy to work with. It's just kind of slow by comparison with what the newer ones were doing. So Amethyst built up this great head of steam, got things working, demonstrated to the community that, hey, Rust can do this. And then they wanted to switch from Specs to Legion. The architectural changes for that became very, very painful. By this point, WGPU was coming along, and the WGPU people will tell you they looked at Amethyst's Rendy system and used it as their template. So Amethyst was the guiding light, but WGPU has turned into a just a better rendering system in many ways. When Bevy came along, the what's his name, Carter, the behind it, one of the posted on the Amethyst list saying, I love you guys. I love all things Amethyst. Bevy is in many ways my attempt at Amethyst 2.0. And Bevy started picking up mindshare. A whole lot of Amethyst developers started working on Bevy. And so inside Amethyst, there's been a debate for quite a while that should we... I say we because Bracket-Lib is actually part of the Amethyst Foundation. Should we be focusing on the Amethyst engine when it's looking like everybody's going towards Bevy? Or should we perhaps look at what we've been doing, recognize that our mission has really been to help get Rust gaming going? And so the Foundation has completely retargeted as supporting Rust game development and trying to help everybody else out.
How do they actually do that now that they're retiring Amethyst?
How they've... let's see. I interact mostly with a fellow named Erland who works with their foundation. They've provided me with a lot of help in things like hosting various projects. One of the things they're really good at is Erland knows everybody. So if you find yourself with a question for how do I do this, he may not be able to answer, but I've yet to run into a case where he can't point me at somebody who can. And I don't know exactly what'll come of there. They were at one point talking about being able to give grants to people to develop cool Rust technology. I just don't know if that's going to happen or not. I'm not deep enough in to see how that works, but
okay, that's good to hear. I think it's good that it seems like they did their mission, right? They wanted to create the engine to prove that it could be created, and I think that makes sense that they kind of stopped there based on, like you said, what the current situation is. So that's good. I guess that's why people kind of gave them a yeah, we support you kind of feedback was what I was kind of hearing on Twitter when I saw this. Okay, is there any other engines that you think that we should be taking a look at?
Those are really the big ones right now. I see RG3D a lot. It is being kind of stealthy in terms of development. I'll just paste the link into the chat for you. It is actually a full-featured 3D engine that works on Windows, Linux, Mac OS, and WebAssembly with a deferred engine system. It is completely not ECS. It uses a render node render graph system, very much like Unreal or Godot. Got a built-in physics engine. Initially, everybody thought it was just for first-person shooters. They've in the last month started releasing tutorials for how do you make an RPG with it. And it's interesting to me that they've got a beautiful editor going, beautiful scene graph going, examples appearing more and more, and really nobody's heard of them. So I have been gradually pointing people towards them because I think it looks really promising. It is on my to-do list over Christmas to get it downloaded and see what I can make with it. In particular, I was just really impressed that they made such a nice 3D editor and really Godot-like asset management. It's a truly impressive looking beginning, and I'm really hoping they can keep it up.
Okay, thanks for putting it onto our radar. I think a lot of people will be checking it out. I think I've seen the name before, RG3D. It looks familiar. But yeah, this is really nice. Yeah, sorry, we spent a lot of time on your book, right? I think, like I said, your book is definitely something that's quite hot, and it's really, really popular. So I'm happy that you can come on here. But you haven't stopped, right? You haven't kind of rested on your laurels, right? You kind of started going on something immediately, although it's much less work than the original book that you did, right? You're working on. Is it actually done and released, or is it still in beta? This is
So Rust Brain Teasers is in beta 1 right now. We'll be in beta 2 hopefully next week. The Pragprog beta system is like Steam Early Access. You get the ebook version and you get each subsequent ebook version as things update. Beta 1 was a little rough and ready in places, but you expect that for beta 1. Beta 2 should be in pretty good shape. I'm hoping beta 3 will be ready for Christmas. It's a much smaller book, like 120 pages, focused on focused on puzzles and things that Rust does that you might not expect. So the format would be, here's some code. What do you think it does? And then the code does this, which is probably not what you expected, and then an explanation as to why what happened. And these range from the moderately fun using Unicode to surprise you, down to really, quite complicated. I tried to allocate on the heap, and it ended up on the stack anyway, and this program crashes in debug mode, but not release. And it's built from my experience of mostly talking to people who've been through hands-on Rust and finding the things that surprised them, putting them into a book, making it kind of humorous. I am intending to pitch a next big Rust book after that. Obviously, I don't think my brain can handle working on 2 books at once and a day job, so get this one shipped and then take a short vacation and work on the next one.
Can you give us a hint about what the next book is going to be, or should we have to wait for that?
It's going to be something to do with Rust and something to do with game development. I'm very much hoping it'll be more intermediate level, so able to assume that you've been through hands-on Rust, and here's how to expand out, enjoy more, learning more of the Rust language. Beyond that, I've not got through the pitching and approval process yet, so I really can't commit to details, or I'm going to upset people because I wrote something else. But
Oh no, that's okay. I'm happy you could at least say that much. So then we have an idea that there's going to be a kind of a part two, right? Hopefully.
Yeah, I think I pitched it as more hands-on Rust, but we'll see how that goes.
Or yeah, next level, level two, something like that. So that's exciting.
Yeah, I've been working pretty closely with the publisher in general. If anybody wants to publish regarding Rust, feel free to contact me. They're looking for anything from very short to 300-page mammoths. Almost any topic. If you want to pitch it, they'll be happy to talk to you. Any other topic, any other language, I can help you find the right person to talk to. But Rust is hot right now. Publishers are really actively scouting out Rust content. It's a good time to be writing about it because Rust is a growing language. But in my case, I've found that I find writing really relaxing. I do this all day long if I didn't have a day job.
Yeah, but I think it's also good to tell people, you're probably not going to get rich from this, but at least if you're going to write a book, make sure you're doing it for the right reason, right? Whatever reason it is, but not to be rich unless you're Obama or somebody who's really a hot softer kind of author. Sorry, I don't mean to bring it down, but I just want to make that kind of clear to the audience that don't expect I can see you right now, right? You don't have a tuxedo on and with a butler next to you, but I mean, you're happy you're doing it, and I think that's the most important part is that if you guys are interested in doing a book, make sure you do it for the right reason.
Yeah, the tech writing world doesn't make a massive amount of money. Bestsellers will make you a nice sum. I mean, I have been enjoying the revenue from Hands-on Rust, and Hands-on Rust is a bestseller for both the publisher, and it's been in the top 5 on Amazon a few times. On the other hand, if you go over to fiction, you write a Harry Potter book and you get in the top 5 on Amazon, then She's Buying Palaces. You go over into the text section, and you're possibly buying a used Volkswagen.
Okay, that's an interesting way to put it, but I'm happy that you made it more down to earth. Yeah, I mean, I'm sure you made quite a bit of money. I mean, obviously you don't need to say around how much, but I have a rough idea about how much you probably made based on. Yeah, I mean, I'm sure it's a decent amount, right? It's a good amount of money, but nowhere near worth the amount of time if you put that time into actually working your day job, I think, or something like that.
I think I figured out I made more than minimum wage, so I'm happy with that.
That's also good too. But the other thing too is Pragprog, I think, is a good author. Good publisher in terms of they. I don't know if they do much promotion in terms of reaching out to podcasts and stuff because we've been approached by Manning to put some of their authors on, so they do a lot of work to try to push their content. At least that's my impression of them.
They are Pragprog. When I started with them, they were doing very little, encouraging the authors to reach out and do it. They've hired a publicist now. Erica's doing a good job of getting started on this. I think you'll be seeing more of them on that front pretty soon.
Yeah, well, I think that the point I want to make is that if you're going to do it for Pragprog, they have a good brand, a good name, but they don't, like you said, they weren't, at least before, they weren't investing into kind of pushing out their authors.
Yeah,
but I do see they're tweeting a lot more now also, like you said, so I just want to kind of reach out on that. That must be the publisher doing that, right?
Yes. And it's funny, Pragprog offer 50% royalties, which is absolutely insane. So anything, if Pragprog makes $20, you get $10, and they split it down the middle for everything. Whereas other publishers, that percentage is a lot lower. So they're getting more of the money, and at the same time, they're doing more. Some of the authors I've talked to have said it kind of balances out. So you might sell, a lot more copies, but you're also only making half the money per copy. So it's 6 of one, half a dozen of the other in a lot of ways. I mean, I went with Pragprog because they're friendly. They're really easy to work with, and they're just, I actually look forward to talking to them, not sort of, oh gosh, I'm going to be hunted down for the next deadline.
Oh, yeah, that's good. I've been talking a little bit to them about a potential book idea that you know about. I'm not going to say too much because still talking. But yeah, I expect at least a month or so of back and forth, I think. before you can probably get something out there, depending on, your idea. I think because you already had something written, it was probably maybe a much smoother process.
It was. I still got rejected once. In the book publishing world, like 70 to 90% of proposals get rejected. If you want to get accepted, you need to talk to them, find out why you got rejected, and then come back with something closer to what they want. That's just kind of how it works. The lady who wrote Harry Potter apparently had hundreds of rejection slips before she could get anyone to print the first one. And that's true in the tech, even more true in the tech book industry, because there's, every publisher has a very specific style, so you have to match that. Plus, you have to hit content, and you have to hit content that excites their board, who may not know necessarily what exactly you're talking about. So it's a complicated process, but it's a little intimidating.
Do you feel that going through the process and writing this book has actually improved your writing? I'm just curious.
Very much so, and my programming too, because when you're writing, so from the English language point of view, write something, send it up to Tammy, my editor, and she will send it back with red ink corrections, telling me fix this, or make some edits. And just like your debugger or your compiler telling you things are wrong, after a while you just start to absorb the good habits. And so I have far fewer pieces of useless punctuation, sentences more on point. Likewise, when you're writing code, the first time you upload to GitHub Public and somebody tells you it's all wrong, it's terrifying. But at the same time, that's really the best way to learn. When Hands-on Rust had a really great beta release and was sitting there on the top of the bestseller list on Pragprog, my inbox just lit up with people telling me everything I'd done wrong. And so I tried to take this as a learning opportunity, not get cranky, just fix it and realize how I could improve it, and then feed that fixes back into the book so everybody benefits. But just like running a big open source project, more eyes on your stuff is scary, but at the same time, it's also really beneficial.
Okay. Overall, I think we spent quite a bit of time together. We went over all in time to spend together. Of course, we talked about 10 minutes before we started. I think I don't have any more questions. I think we went over quite a lot of stuff, and I'm happy that you could give me, at least me, more visibility about the game development kind of area. Is there anything else you wanted to say before we sign off?
Not off the top of my head. If anybody wants to know more, feel free to contact me. Apart from Gmail apparently blocking things at random, I love hearing from people. Twitter is the most reliable way to get a hold of me. So I love answering questions. And thank you so much for having me.
I just want to also say, we mentioned this before we started recording, but yes, I think I was blocked by whatever issue Gmail had. Maybe because my emails are coming from Hong Kong or something. Maybe they don't like that. I don't know. But yes, reach out to him over Twitter. DM is probably the easiest way, and you're very responsive, so I appreciate that. I just want to kind of follow up with that yes, I was blocked, so it happens, and I'm quite surprised.
Yeah, I was too. I'm sorry about that, but it doesn't tell me who it's blocking, so I have no idea until somebody finds me another way.
No need for you to be sorry. That's just something we find out. So sometimes people don't want to reply, and then sometimes people just didn't even know that they can reply. So let's not worry about that. Now I think you need to be in a habit of checking spam. I usually check that every day or whatever. Just say get random stuff. Actually, the funny thing is, even I get some of my employees. They also get their emails sent to my spam, which is even weirder. I don't know what happened with that. Maybe I put them in spam somehow. I don't know. It happens. Things happen. Anyways, again, thank you for your time. Maybe we can have you back again to talk more about the Brain Teasers book in particular, or maybe whatever. So other than that, thank you for joining, and yeah, have a nice day.
Thank you so much.